Hello everyone. Today we are going to learn the modulation index and what is the importance of the modulation index in the amplitude modulation. So let's go on CRT screen and see what is the modulation index. If you will understand the video lecture, then hit the like button, share with your friends and subscribe the channel for the more. Today we are going to learn this modulation index, the modulation index and the importance of the modulation index in the amplitude modulation. The amplitude modulation we had seen in our last video lecture, and we've seen the definition of the amplitude modulation. Then we've seen what happens in the amplitude modulation, means we had seen the process of the modulation. Then we had seen the various definitions, as well as we had seen the process and its waveform of the modulation of the amplitude modulation. The equation we derived for the amplitude modulation, and today we are going to learn this modulation index. The modulation index is decide the quality of the transmitted signal, the quality of the modulating signal. The three signals are involved. First one is we call the modulating signal. Second one is we call the carrier signal, and third one is we call as a modulated signal. Okay, so we derive the formula for the amplitude modulated signal, and the amplitude modulated signal is the product of the carrier and the modulating signal. It is the product of the carrier and the modulating signal plus the carrier signal. Okay, so that is the equation of the amplitude modulated wave. Now here we have to see the modulation index and its importance. The modulation index definition we will see, and that definition is in the amplitude modulation. In the amplitude modulation, the modulation index is the ratio of the modulation index is the ratio of the two quantities. Which are those quantities? First one is the Vm. What is Vm? Vm is the peak value of the modulating signal to the second quantity, and that second quantity is the Vc. It is the peak value of the carrier signal. So we can say modulation index is the ratio of the peak value of modulating signal to the peak value of the carrier signal. The modulation index is also called as a modulation factor or a degree of the modulation, and it decides the quality of the modulated wave. Here we can give its formula as m equals to Vm by Vc. The modulation index is also given by using the percentage, and here the formula is for the percentage is percentage m equals to Vm by Vc. It is the m multiplied by 100%, multiplied by the 100%. The modulation index is the ratio. So this ratio is given by m equals to Vm by Vc, and the percentage modulation means percentage m is equals to Vm by Vc multiplied by 100%. So if we consider the value of the modulation index m, then this m is in between the 0 to 1, means the percentage of the modulation maximum equals to 100% and minimum it is equals to 0%. The modulation index may be the 0 or it may be equals to 1. So here the modulation index is the ratio of the modulating signal voltage or the peak value of the modulating signal voltage to the peak value of the carrier signal voltage. Okay, now we have to see here the importance of the modulation index. The modulation index is important because of the quality of the signal. The quality of the modulated signal is decided. The quality of the modulated signal is decided by the modulation index, by the percentage of the modulation, by the value of the modulation. So therefore here the modulation index is important, and here the modulation index is decided by using the values of the peak value of modulating signal to the peak value of the carrier signal, that is Vc. So the value of modulating signal, either peak value of modulating signal, either Vm is greater than the peak value of the carrier signal, and the modulating signal may be less than the peak value of the carrier signal, or it may be equals to the peak value of the carrier signal. So the modulating signal voltage, and we can say the carrier signal voltage, gives the quality of the output signal. Means whatever the modulated signal is there, that modulated signal is decided by using the quality of that modulated signal is decided by the peak value of the modulating signal and the peak value of the carrier signal. So therefore here it is necessary to see the effect of the modulation index on the quality of the signal, or we can say the output modulated wave. As in the amplitude modulation, the information is important. The information we transmit, that information is we call as a modulating signal, and we had seen that in amplitude modulation the information is available in present in the variation of the carrier signal. It is present in the variation of the carrier signal. So the modulation index determines the strength and the quality of the signal. That's why there is an importance of the modulation index, or we can say the percentage of the modulation. Here we can use the three values of the modulation index. When the modulation index is low, or we can say when the Vm, the modulating signal voltage, is greater than the carrier signal voltage. When the modulating signal voltage is greater than the carrier signal voltage, this is the first condition. The second condition, when both are the Vm and Vc both are equal, and third condition we can consider, that third condition is when Vm is less than the peak voltage of the carrier signal. Vm is less than Vc. So these are the three conditions. These three conditions we will say one after one, but we also say the effect of this value of the Vm and Vc on the output waveform. So we have to draw the output waveform and we have to describe, or you can draw this all three output waveform and then you can describe one by one. Okay, so the first condition is the under modulation. What condition we call under modulation? When the value of Vm is less than the value of Vc. Vm is the peak voltage of modulating signal and Vc is the peak voltage of the carrier signal. If the modulation is done, and while doing the modulation, here when the modulating signal voltage or peak value of the modulating signal voltage is less than the carrier signal voltage, where the m is less than 1, then it is we called as the under modulation. It is we called as the under modulation. And if you see the waveforms drawn below, in that waveform here we get the value of the Vm and the value of the Vc. Here it is the value of the Vm and this one is the value of the Vc. So the peak voltage of modulating signal Vm is less than the peak value of the carrier signal. When we do the under modulation here, the percentage of the modulation is less. The transmitting signal having the less strength, but there is no distorted output. The output distorted, it means some part of the output is not available, or you can say here there may be an interference of the other signal. So when we do the modulation, that modulation is the perfect modulation. The under modulation is the condition when the Vm is less than 1 or the modulation index is less than 1. This is we call the under modulation. In under modulation, the amount of the carrier amplitude variation is small. There is a less variation because the variation is according to the modulating signal voltage. As the modulating signal voltage is less, so the variation of the modulated signal is, or we can say the carrier signal is the less. It produces the signal with the less strength. The strength is less, but there is no distorted output. That's why here the under modulation is having the quality, but it is not the pure quality signal. Okay. Then next one is when the modulating signal voltage Vm equals to the carrier signal voltage Vc. Vm equals to Vc. At that time, the modulation is we call as a perfect modulation. The modulation is we call as a perfect modulation where the percentage of modulation m percentage equals to 100%. It is equals to the 100% and the value of m is equals to 1, where in perfect modulation the value of Vm is equals to Vc. This is we call as a perfect modulation. If you observe the waveform, then you get here the change in the Vc is almost equals to the peak value of the Vm. Here this is the peak value of the Vm. It varies up to the peak value of the Vm. Here at this point it varies up to the minus Vp, means negative peak value of the Vm. Okay, so when we do the modulation and at that time if the modulating signal's peak voltage is equals to the carrier signal's peak voltage, then it is we called as a perfect modulation. In perfect modulation, the modulation percentage equals to 100 and the modulation index m is equals to 1. So here the perfect modulation is desired. When we do the perfect modulation, here the signal produced, that signal is a stronger signal and the more intelligible signal is there and the information available, that information is the not distorted. The signal we get, that signal having the sufficient voltage and there is no distortion. Okay, so we had seen the two conditions of the modulation. When Vm, the modulating signal voltage we considered, Vm is less than Vc, it is we called as the under modulation. Second condition we had seen, that second condition is when Vm is equals to Vc. Here the percentage modulation is equals to the 100%. In this perfect modulation, Vm value is equals to Vc. So it is we call as a perfect modulation. Okay, the perfect modulation is desired, means when we do the modulation, the perfect modulation is desired, but we cannot do the perfect modulation because of the limitations of the electronic circuitry, as well as here we don't know the value of the Vm, that changes according to the strength of the input signal. Okay, so that's why here the modulation index is not equals to the 100% or it is not a perfect modulation. The modulation is always either under modulation or the modulation is the over modulation. The over modulation is the third condition. In over modulation, Vm, the modulating signal voltage, is greater than the carrier signal's peak voltage, where m is greater than 1 and the percentage of modulation is more than the 100%. This is we call as the Walker modulation. The Walker modulation is the modulation in which we get the Vm is more than Vc. If we draw the waveform, then we get this kind of waveform where some part of the modulating signal, some part of the modulated signal gets clipped. The waveform required, that waveform is like this. The waveform is required after the modulation is like this, but some part of this signal gets clipped. This one part gets clipped. So here the information is absent. Here the signal gets clipped. So information is absent. Therefore here it produces the output. That output is the distorted output. The signal is stronger. The signal is having the sufficient strength. The signal is having the sufficient power at the output side. But one thing is that there is a distorted signal at the output of the modulated wave. So therefore here the over modulation is undesired. We not need to do the over modulation. Here the negative peaks in the over modulation, the negative peaks gets clipped. So therefore here it produces the distorted output and here it is undesirable. We not required to produce the distorted output. So here if there is a distorted output means there is a lack of the information. More noise is available in that signal. Okay. The question is asked. If the question is asked like this, what is the modulation index? The question is, what is the modulation index? Explain the importance of the modulation index. Then what to do? Just you have to write down the definition of the modulation index. You have to write down the definition of the modulation index first, and then you have to write down what is the importance of the modulation index. Three conditions you have to write down here. First condition is the under modulation, second condition is the perfect modulation, and the third condition is the over modulation. You have to give the definition of each of the modulation in that. The first one is the under modulation, second one is the perfect modulation, and third one is the over modulation. You have to write down the definition as well as you have to draw effective waveform, and you have to write down the effect of the modulation on the output. Okay, so you can draw the separate waveforms of the under modulation, perfect modulation and the over modulation, or you can draw the common diagram for all of these. Okay, this is the common diagram. Here the first waveform is for the under modulation, where you have to show Vm is less than Vc, m is less than 1, and then the second one is the perfect modulation, where you have to show Vm is equals to Vc, m is equals to 1, and third diagram is for the over modulation. Here you have to show Vm is greater than Vc, m is greater than 1. Okay, then here the examples we have to see, but before that example we have to see what if there is a modulation index we have to find out and the signal is displayed on this CRO screen. So here the modulation index, if we have to find out, then what we required, the M is equals to Vm by Vc. M is equals to Vm by Vc. If we have to find out the modulation index, percentage of modulation, then we can use this formula. But what if the signal values, the signal voltages you not know, and the signal is displayed on the CRO screen? If we have this type of the waveform displayed on the CRO screen, then we can easily find out the modulation index by determining the minimum and the maximum voltage. Now you just need to know what is the peak value of the modulating signal and what is the peak value of the carrier signal. Okay, so the peak value of the carrier signal, if you have to consider, then the peak value of the carrier signal is up to this point, up to this point. Okay, here the modulating signal voltage is here, the modulating signal voltage is equals to 0, and as we know, the carrier signal varies above the peak voltage of the carrier signal. The modulated signal waveform, if we see that we drawn before, this is the simplified waveform. But that waveform, if we see, then we get the modulating signal voltage varies above the peak voltage of the carrier signal, and it varies below the peak voltage of the carrier signal. And we know that at 0 volts of the modulating signal voltage, the peak voltage remains constant, means the modulated signal voltage remains constant. So here at this point there is a modulating signal voltage value is equals to 0, means this point is the peak voltage of the carrier signal. Okay, so we have to find out this point voltage, means this much voltage. It means here this voltage is equals to the maximum voltage, this one voltage. Okay, the peak voltage we have to find out, and for the peak voltage of this carrier signal we require to know the modulating signal voltage, that is the Vm. We require to know the Vm, and Vm is what? Vm is the peak value of the modulating signal voltage. If we have to find out the Vm, then here we can give that Vm as the Vm equals to the total voltage, this one voltage, minus the V minimum. Okay, means V maximum total voltage, V maximum minus the V minimum, V maximum minus V minimum, that gives us the peak to peak voltage of the modulating signal. And as we know, the peak to peak voltage is the double of the peak voltage. It is the double of the peak voltage. Therefore, we can give the formula for the Vm, and the formula for the Vm is V maximum minus V minimum divided by 2. V maximum, this much maximum voltage from this point to this point. This is the total voltage. From that, what is we have to subtract? We have to subtract the V minimum. Okay, we have to subtract the V minimum, and this is the peak to peak voltage. We required only the peak voltage, so it is divided by 2, means we get the peak voltage. V maximum minus V minimum divided by 2 is the peak value of the modulating signal voltage. We require to find out the carrier signal voltage, the peak value of the carrier signal voltage. If we observe the waveform again, then we get here the peak value. Here it is the peak value of the carrier signal. If we minimize the peak value of the modulating signal voltage from the maximum voltage, if we subtract the Vm, from this V maximum, then we get the value of the value of the Vc. So here we get Vc equals to V maximum minus Vm, and if we put the value of this Vm, then we get here Vc equals to V maximum minus V max minus Vmin divided by 2. After solving this, we get Vc equals to V maximum plus V minimum divided by 2, means Vm equals to V max minus Vmin divided by 2, and the Vc equals to V maximum plus V minimum divided by 2. Okay, we have to find out the the modulation index. So modulation index can be given by the values of the both voltages, the peak voltage of modulating signal voltage divided by the peak voltage of the carrier signal voltage. It is equals to V maximum minus V maximum minus V minimum divided by V maximum plus V minimum. If we have to find out the percentage modulation, then we get it is the M multiplied by 100%, means Vmax minus Vmin divided by Vmax plus Vmin multiplied by 100%. Okay, so this is the modulation index in terms of the Vmax and Vmin, or you can say the modulation index. How to find out the modulation index? When the signal is displayed on the CRT screen. Once again, we will see how we find it, the Vm, value of the Vm, and the value of the Vc. Vm is the modulating signal voltage. If we see the waveform, this is the modulating signal voltage Vm. From this point to this point is the Vm. Okay, if we subtract the Vm from the Vmax, then we get the peak to peak value Vpp, peak to peak value of the modulating signal voltage, and Vp equals to V peak to peak divided by 2. So therefore here we get it is Vmax minus Vmin divided by 2. Okay, so we get the value of the Vm. Now if we have to find out the Vc, Vc is what? Vc is the peak value of the carrier signal. Now if we subtract the Vm from the maximum value, if we subtract this much value from the V maximum, then we get the peak voltage. Okay, so Vc is equals to V maximum minus what? Minus Vm, peak value of the modulating signal voltage. Then here we get the Vc. If we put the value of the Vm, then we get the Vc, and if we solve that equation, then we get Vc equals to V maximum plus V minimum divided by what? Divided by 2, and then we can calculate the formula for the modulation index M, that is V maximum minus value of the Vm divided by 2, and value of Vc, which is Vmax plus V minimum divided by 2. So we get Vmax minus V minimum divided by V maximum, Vmax plus V minimum. Okay, this is the modulation index. If we have to find out the percentage modulation, then by multiplying 100%, we get the percentage modulation. So, okay, in this video lecture, we had seen what is the modulation index, what are the importance of the modulation index. By using 3 conditions, we seen the importance of the modulation index in the AM. First, we seen the modulation index means the under modulation. Then we say the perfect modulation. The under modulation is when the modulating signal voltage is less than the peak signal voltage of the carrier. The under modulation is the modulation in which the Vm, the peak voltage of the modulating signal, is less than the peak voltage of the carrier signal. In under modulation, we get this signal without distortion. The signal strength may be low, but there is no distorted output. Okay. Then second one is the perfect modulation. In perfect modulation, there is no distortion, as well as the signal strength is very high. It is desired, but we cannot produce the 100% perfect amplitude modulation. Then third one is the Walker modulation. In Walker modulation, the Vm, the modulating signal voltage, is more than the carrier signal voltage. This is we call Walker modulation, where m is greater than 1. M is greater than 1, and here if we do the Walker modulation, then some part of the signal, some negative part of the signal gets clipped, so therefore it produces the distorted output, as well as we get the waveform. That waveform is flat after the positive peak, and here if we transmit the signal, then there are more chances we get the distorted output. Even if we transmit the signal, then we get the signal interfere with the other signal. Okay, then we are saying how to find out the modulation index and the percentage modulation if the signal is displayed on the CRO screen, and where we use the maximum and the minimum values. Okay, next time we have to see the side bands and the importance of the side band. Then we will see some examples on the amplitude modulation to find out the modulation index, to find out the percentage modulation and the other quantities. Okay,